Hey guys, welcome back. Sorry about that last video. I hope you guys didn't miss me too much. Now we are going to move on to triangle similarity. So if you see up here, we have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So these two at least should look familiar to you because when we proved that triangles were congruent, we had side-side-side and side-angle-side. And you guys kept asking about angle-angle, and I told you we would get to it later. So you should be excited because we're doing it now. So take a look at the first one. We're going to talk about angle-angle similarity first. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So we can take a look at the picture that we have here. Angle A has one arc mark, angle D has one arc mark, so they're congruent. Angles B and E both have two arc marks, so we know that they're congruent. So we can say that the triangles are similar to each other. When you're writing that triangles are similar, kind of like we were doing with our polygons in the last section, triangle ABC is similar to, and the order does matter, so angle A was congruent to angle D, which means D has to come first. B is congruent to E, so that has to come second, and then F. So just like with congruence and just like in the last section when we were showing the polygons are similar, when we're saying simply just triangles, we need the triangle symbol and we need the order to matter. The order does matter. All right? Next is side-side-side. So if three sides of one triangle are proportional to the three corresponding sides, I got ahead of myself. Three corresponding sides of another triangle, then the triangles are similar. So if we look at the triangles over here, they're telling us that AB is proportional to DE. So AB and DE are proportional. And then AC is proportional to DF, so that's over here. And the last one they show us is BC is proportional to EF. So, since all three sides are taken care of, we can say that the triangles are similar by side-side-side similarity. So triangle, and again, be careful with the order. That's why I colored them different colors so we can figure that out. If I want to go ABC, I can say that that is similar to triangle DEF. They're not always going to look exactly, they're not always going to be exactly the same order, so make sure that you are careful with that, all right? The last type of similarity that we have is side-side-side. So if two sides of one triangle are proportional to two sides of another triangle, and their included angles, bringing back some vocab here, their included angles are congruent, then the triangles are similar. So when we look here, AB is proportional to DE, and then BC, I know my letters, guys. BC is proportional to EF. And when we look, their included angles are B and E. Those angles are marked congruent, so we know that the triangles are similar by side-angle-side similarity. So by going in order, triangle ABC is similar to triangle DEF. Now keep in mind you can start at another spot if you want, as long as you go in the correct order. So we could have said BCA to EFD, or you could have said CBA to FED. You can change up the order as long as you've still got the matching corresponding parts. Cool? All right, let's look at some of these example problems. We have to determine if the triangles are similar. If they are, we have to write their similarity statement and we have to show our work and we have to use whichever reason applies. All right, so looking at these triangles here in number 1, I'm sure you guys, the first thing you see is the box there to show that they're both right angles. So we've already got one set of congruent angles because angle G is congruent to angle L since they're both right angles. But then we have to look at those other angles there. So if you remember, a triangle has to add up to 180 degrees, which means that when we're looking at this, angle F is going to have to be 29 degrees. And so we luck out because they already told us angle J, sorry guys, I can't speak today. Angle F is congruent to angle J because they're both 29 degrees. We don't even have to find the other angle, although you guys can. You can tell me that it's 61, but it doesn't matter because really the most we need is two angles because the third one is going to have to be congruent if the first two are. So we know that they are similar to each other. In our similarity statement here, we want to go in order, so H, G, F is similar to, if I started at H, I need to start at K, so K, L, J, which is my mom's initials. Looking at number 2, when we look there, we're only given one angle, but they are congruent to each other. So we've got that 61. So we're going to have to look and see if the sides are proportional then. So when we look here, AC is going to need to be proportional to one of these sides. And when you look, this one's 3 and this one's 6. This one here is 5 and 10. So take the shorter one then, AC to DF. And then we're going to have CB and FE. And we want to know if those are actually proportional to each other or not. So 3 to 5 and 6 to 10. And you can use your calculator to make sure, but 6 to 10 does simplify to 3 over 5. So yes, those sides are proportional, and their included angles, are congruent. So these ones are similar by side angle, side similarity. And then we need to write our similarity statement. So ACB is similar to triangle DFE. Cool? You guys should be pros at this. This is not tough stuff. All right? Bear with me, just a couple more practice problems to look at. This one is going to bring back some stuff that you guys hopefully remember. But first things first, anytime you see that bow tie shape, you're supposed to think about vertical angles. So angle PQT and angle RQS, those ones I just marked in there, are congruent. I'm going to zoom in a little bit because this picture is a little bit smaller. But those two angles are congruent to each other. And then we also see, hopefully, you guys recognize those symbols right there. It means those lines are parallel. So I'm going to extend them out just a little bit so we can see what's going on. Anytime we have parallel lines, we're going to get congruent angles. Does not matter which transversal you pick. I'm going to go ahead and pick this one here. But if you pick the other one, it would work out too. It doesn't really matter. Either way, we're going to get some more congruent angles. So in this case, I got angle T and angle S to be congruent. But if you use the other transversal, you will get P and R. And that would be okay too. But we can see then we've got some angle-angle similarity. So these triangles are similar to each other. So triangle, I'm going to start at T and go to Q. So T, Q, P. The reason I do that is because then I started at the pink angle and I went to the green. So my order over here, I'm going to start at pink and go to green also. So triangle S, Q, R. I think using colors helps, guys. I think doing little tricks like that is going to help, because back when we did the congruence, triangle congruence, some of you did have some trouble with the order. So if that helps, do it. Number 4, we've got these overlapping triangles here. So I think your best bet is going to be to draw them separately. So I'm going to draw the little one over here. We've got A, X, Y. So AX is 20, AY is 25. And then the big triangle that we have is ABY. BC. Now AB, make sure you add these two pieces together, guys. So it's 45. And AC, again, it's this whole thing, so it's 55. If you're having some trouble seeing that, we can kind of draw some brackets to show that it's the big triangle. Now the thing about it though, we're only given those two sets of sides, right? So you have to recognize that because there are these overlapping triangles, they both share angle A. So if we could get those sides to be proportional, kind of like we did in number 2, then we can say that the triangles are similar to each other. So when we're looking here, the smaller side in this triangle is AX, and the smaller side in the big triangle is AB. So we want to know if they are proportional to AY and AC. So AX is 20. I'm going to put a question mark there because we don't know for sure, right? So 20 to 45, and we want to know if that's proportional to 25 over 55. Now when you put those two in your calculator, the first one you get is 4 over 9. The second one is actually 5 over 11. So those ones are not equal to each other, which means these triangles are not similar to each other. That's why you've got to check, guys. You've got to show all this work here, okay? All right, 2 more examples, and then you guys are done for today. So take a look at the next page. We're going to look at number 5 first. Let me move over. There we go. All right, so again, you see that bow tie shape, right? Bow tie shape always means vertical angles. So angle TXU is congruent to angle WXV, those 2 pink angles right there. So if we could somehow get their sides to be proportional, then we would be good. So let's take a look at this triangle over here. The smaller side is TX. And the triangle over on the right, the shorter side is VX. So we want to see if those are proportional. And then we've got the longer side in the first triangle is UX. Longer side in the second one is XW. So let's see if those are proportional to each other. So TX is 12, VX is 16, and 15 over 20. And we luck out 3 over 4 and 3 over 4. You guys can't see. Sorry. So the sides are proportional and their included angles are congruent, which means they are similar by side angle side similarity. This is why it's important to match up the shorter side with the shorter side and the longer side with the longer side, because it's almost flip-flopped, right? The 15 and the 20 are the ones we're putting together, and the 12 and the 16 are the ones we're putting together. So you don't want to just assume that the 12 and the 20 or the 15 and the 16 go together, all right? Now that we know that those are similar, we need to write our similarity statement though. So if I want to start at T, TXU is going to be similar to triangle. Since I went across the 12 first, I have to go across the 16 first. So VXW. Cool. I hope you guys are doing all right with me. One more. This one, I think this picture is a little hard to look at, but I'm going to help you guys out and draw one of them purple. And let's draw that down here. Hopefully you guys can see though that PRQ, so I did turn it a little bit, but PRQ is an isosceles triangle. PR is 6 and the other 2 sides are both 4. So I'm going to draw that one there. And then we also have PRS, so this green one over here that I'm going to draw. And PRS is also isosceles. It's 6, 6, and 9. So we're not given any angles here. we're going to have to check all of the sides. Our only option is going to potentially be side, 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 or they're not similar. So I would probably start with PQ and PR because it's 4 to 6. And then look, Q to R, R to S is also 4 to 6. So we know those are the same for sure. And then look at the two bases of your isosceles triangles. It's 6 to 9. And then we can check, and all of those simplify down to 2/3, which means all of the sides are proportional. So we can go back up here. They are similar by side, side, side similarity. And we can do triangle PRQ, similar to triangle PSR. All right, yes, you have to show all of the work here to show me that all the sides are proportional. You have to mark congruent angles when necessary, all right? We're going to do a ton of practice for you guys to see the difference between side, side, side similarity, side angle, side similarity, angle, angle similarity, and some cases where they're not actually similar. So we'll do some practice tomorrow. If you have questions on any of this, ask me as soon as you get to class, all right? I'll see you guys later. Bye.